Now, those were very simple probabilities. Most probabilities are a little bit more complex and talk about unions and intersections and complements. So it's important that you know what a union is. The union means that you're taking everything. Intersections have to have both things. Think about a road. An intersection is at a corner. Um, it's only where both of the two roads intersect. So sets are the same way. We only take what they have in common. And complements of sets are everything not in that set. Okay? So if E is an event, the complement of E, nope. And in this textbook, the complement of E is designated or denoted with a capital C, or a capital E with a to the C power, with a little c for complement. Sometimes you see it differently. Sometimes you see it with a bar over the E, or a little apostrophe, or even sometimes like a little hat. There are different notations for it, but this book, you're going to see E to the C power, means the complement of E, is the event that E does not occur. The probability of E to the C can be calculated just like this, like we already saw in the previous section. 1 minus the probability that it does occur. So what is the probability that you will guess correctly on a multiple choice test with 5 possible answers? Well, if it's a multiple choice test with 5 possible answers and you're just going to guess at random, we assume only one is correct, right? So the probability would be 1 out of 5. So now, what would the probability be of guessing and not getting the correct answer? Well, since that's the complement of this, we can think of it as 1 minus 1/5, which is just 5/5 minus 1/5, which is 4/5. And we could have done that without the complement, but it's a very simple example to see that it's just 1 minus the complement of it, because we know that if we have a multiple choice test, there are 5 possible answers and only 1 is correct. There are 4 that are incorrect, so the probability should be 4/5 that you guess and don't get the answer right. So if E and F are events, let's look at now the intersection. The intersection of E and F is denoted like this. That is like almost like an upside down capital, or like a capital A, a curvy capital A without the line. And because it's also sometimes pronounced as and, E and F, because we want both of those things to happen. But it is the event that both E and F occur. E intersect F. So let's consider this table below and answer the following question. What is the probability of that a randomly selected student is older than 30 and is majoring in a lab science? Okay, so when we read this chart, we're looking at this column is people who are majoring in a lab science. This column, people who are not majoring in a lab science. This row says that these are the people in this row that are over 30. These are the people in this row, in the second row, that are not over 30. Okay, so if we are looking for somebody who is older than 30 and majoring in a lab science, we're looking here at this group, this row, and majoring in a lab science is this column. Where do they overlap? They overlap right here. at 400. So out of the total number of people, 9,000, there are 400 that are majoring in a lab science. So we could say the probability that you are older than 30 and majoring in lab science is 400 over 9,000. And a lot of times with probabilities, we'll reduce that to 4 over 90, which reduces, if you care to reduce it, 2 out of 45. Now with probabilities, I tend to leave my probabilities as fractions because that's one area that I like fractions is in probability, because that tells me 2 out of 45 of those people, out of every 45 people at this school that are 2 of them are over 30 and majoring in lab science. So it's easier for me to see that than a decimal. But a lot of times in the textbooks you'll have them, the answers will be given as a decimal, and you just take 2 divided by 45 and write the decimal down. On a quiz or a test, it would not matter to me how you gave the answer, as a fraction or a decimal. Okay. So let's go ahead and now look at the union. If E and F are events, the union of E and F, which is denoted like this, E union F, and it looks like a big U for union. And sometimes we say or, E or F, because that's all that means. It is the new event that either E occurs or F occurs. But it doesn't have to be both. It only has to be one. So finding probabilities of unions are much more difficult than finding them of intersections. So what we'll do is we'll look at what's called a hypothetical 1000 table. So you may only know probabilities for some events. In this case, it's often possible to create what we are going to call a hypothetical 1000 table, and then use the table to compute the probabilities. Okay, and let me show you how to do this, because these tables are used to compute probabilities of intersections and unions of 2 events. So let's take a look at this example. We have this report from TV, drama, comedy viewers, and health information. It describes a large survey that was conducted by the CDC. And so, first of all, the CDC believed that their sample was representative of adult Americans. Okay, so you need to have a representative sample when you're dealing with any kind of statistics. So L is going to be the event that a randomly selected adult American reports learning something new about health issues or diseases from a TV show in the previous 6 months. F is the event that the randomly selected adult American is female. So these are the things that we know. We know that the probability that somebody reported learning something new was 0.58. The probability of female, that the American adult was female, was 0.5. So basically half were female, half were male. And the probability of the intersection, so that meant that the person said they learned something new within the 6 months and they were female, was 0.31. So what we want to do is find the probability that a randomly selected adult American has learned something new about a health issue or disease from a TV show in the previous 6 months or is female. That "or" right there tells you that this is going to be a union. Okay? Either they learned something or they are female. It doesn't have to be both. Both would be the intersection right here. Right? So this is what we're doing to create this table. Since the probability is 0.58, if we had 1,000 people taking our survey, that would mean that 580, or 0.58 times 1,000, if the probability is 0.58, then we would end up with 580 people learn something from TV. Okay, 580 out of 1,000. We do not know if they were female or not female. We just know that 580 of them learned something. Now we're also told that the probability that they were female, okay, so here's our column of female, there were 500 out of 1,000 because the probability is 0.5 or half. So half were 1,000, or half of the 1,000 were female, so that means that 500 of them were not female. We also know that the intersection of learning something from TV and being female, this intersection right here, was 0.31. So if I multiplied 0.31 times 1,000, I'm going to get 310. That's the number that I'm going to put right here in the intersection of learning something from TV and female. So now I can fill in the rest of the chart because I know that the number of people that learn something from TV has to add up to 580. So if 310 people, females, learned something from TV, then that means that 270 of the not females must have learned from something from the TV. Okay, then we can fill in our middle numbers by looking at the columns. 580 plus 420 add up to 1,000. If we know that there were 500 people who are not female and we've accounted for 270 of them here, then this must be 230. And if there were 310, or there were 500 females and we've accounted for 310, then there must be 190 here. Okay, so the columns will all have to add up to the total and the rows will all have to add up to the total, and these are what we call marginal totals because they're in the margins. Marginal totals, and they will add up to the grand total. So you can add up vertically or coming across horizontally. So what we want to do is find the probability that somebody learned something or they were female. Okay. So how do we figure out that? Well, if they learned something from TV, or if they were female, means that they're going to be in this group, or this group, right? The 310 and the 190 are females. These 310 were females that also learned something from TV, but this 190 were females that didn't learn anything from TV. And then when we look at this cell, to the 270, those were people that were not female, but they did learn something from TV. So when we look at this, we have 310 plus 190 plus 270 out of the 1,000 people. So if we add that up, we get 770 out of 1,000, which is 0.77. So the probability is 0.77 that either the person learned something from TV or they were female. Okay. So it is a little bit more difficult, but you'll have a chance in the homework to practice this.